Hello everyone, this is Haddad here again. We are now doing lab number 4 in this course, and it's about the authentication on OSPF. Before we start going through all those points of the lab as you can see here, let's first go and see what is our lab scenario. Here is the lab scenario. As you can see, we have router 1, router 2 and router 3 that are connected as a triangle. And on Ethernet 2 of router 1 is connected to Ethernet 2 of router 2. And I always try to make the subnet between the routers easy for us to remember. So you can see here I made it 192.168.12.0. 1.2 means there's a connection between router 1 and router 2. Between router 2 and router 3, I say 192.168.23. Between router 1 and router 3, I say .13 means from router 1 to router 3. And also, I always try to put here the last octet, which is .0. For Ethernet 2, I put it .1 because that belongs to router 1. And Ethernet 3 also .1. On router 2, we can see here .2.2 and here .3.3. Okay, so this is what our diagram is. And then we are all having all those routers inside the area 0.0.0.0, which is the backbone. And on each of the router, I have created a bridge interface, and I put an IP on this bridge interface. Router 1, 11.11.11.11, router 2, 22.22.22.22, and router 3, 33.33.33.33. All are /24. Okay, so this is what is our lab scenario here. We have now to go and see what we have to do in the points. Point number 1. All IP addresses are already configured as on the picture, including the bridge interfaces. Okay, so this is already configured. We don't need to do it again. You can do it yourself, but for me to win the time in this lab, the IP addresses are already set as on the picture. And the picture again, you can see it on the top of the screen, also to be able to follow the lab correctly. So this is done. Number 2, OSPF is enabled on each routers. The router ID are added and the networks are advertised. Okay, so I also have enabled the OSPF on each of the routers. I have added also the router ID, and also I have added the networks. The router IDs, it's not shown in the picture, but it's as always we do. The router ID for router 1 is 1.1.1.1. Here is 2.2.2.2. And here 3.3.3.3. So this is also done. Now, add manually on OSPF Ethernet 2 and 3 on router 1, Ethernet 1 and 2 on router 2, and Ethernet 1 and 3 on router 3. So why we need to add it manually now, the interface inside the OSPF? Because we need to make a change on the authentication, and this happens only inside the interface. For example, if we go here to router 1, you can see already we have enabled OSPF. And if we go now to routing OSPF, that's on router 1, yeah? These networks I have already advertised everything, and directly you can see that the interfaces will be listed here, but they are listed as dynamic, okay? Because after we advertise the networks, they will be advertised here also the interfaces dynamically. But if I want to, for example, to go inside the dynamic interface and make some change here, I cannot. You see it's locked, okay? I cannot do that. And for the authentication, as for the priority, if you remember when we were doing the lab for DR, this happens inside the interface. So we need to make change inside the interface. That's why we need to add it manually. And I will show you now. So we will add on router 1, Ethernet 2 and Ethernet 3. So I will go here now manually. I say I want to add Ethernet 2. And when I say OK directly, you see that this manually will be shown. And the dynamic will go, okay? So now again, I go to plus here, and I'll add Ethernet 3. You see here now, dynamic is gone. Now, if I go inside Ethernet 2, for example, I can now play with the priority for DR in case we're doing lab for DR, or inside here for the authentication, okay? So this is for router 1 is done. Router 2, we have Ethernet 1 and Ethernet 2. So router 2, we go to routing, OSPF, interfaces. We need to add Ethernet 1 and Ethernet 2 manually. The bridge, we can leave them, that's no problem, because we're not doing authentication on the bridge. So, Ethernet 1 and Ethernet 2. And then on router 3, we need to add Ethernet 1 and Ethernet 3. Then on router 3, we go to routing, OSPF, interfaces, we add Ethernet 1 and Ethernet 3. Okay, this is done. Check if routers have formed neighborship and the routes are added. So because we now just made small change, we have to see if there is neighborship between the routers. Now I'm on router 1, I will go to neighbors. You can see router 1 is forming neighborship with router 2 and router 3. That's the router IDs of the two routers. And for the routes, we can see here directly that router 1 is knowing now about this bridge interface from OSPF of router 2, and this is the bridge interface of router 3. Okay, and also the link between router 2 and router 3. Okay, and you can see over here that everything is state is intra area, that because those routes are inside the same area, which is the backbone area. Okay, so we go to router 2. We check the neighbors. Router 2 having neighbor with router 1 and router 3, that's fine. And we see the routes here. Router 2 now know about 33.33 and 11.11. Okay, and he knows about the route between router 1 and router 3. Okay, same does router 3. Neighbors. Router 3 forming neighbors with the two other routers, and here are the routes. Okay, router 3 knows about the route from router 2, which is 22.22 and 11.11. And also 192.168.12. That's the link between router 1 and router 2. Alright, that's fine. So that means that all our configuration is correct till now. That's okay. Now we start now doing the authentication. Configure OSPF authentication using simple method between router 1 and router 2. Put the password 123456. If we go back to the picture here, we need to enable a simple method between router 1 and router 2 and putting the password 123456. That means we have to go inside Ethernet 2 of router 1 and Ethernet 2 of router 2 and do this change. Okay, let me go to router 1. Inside the interface, I have to go to Ethernet 2. And inside here, you can see authentication. These are the three types: none, simple, and MD5. That's what we have just seen in the previous lecture. I'll put it simple. And they said they want it to be 1, 2, 3, 4, 5, 6. I will keep the authentication key ID 1. We will talk about it now in a moment in this lab. Okay. But now what will happen, if I just now click OK, router 1 and router 2 will not form any more neighborship, because if we remember that the authentication is inside the hello packets when they share hello packet, and the hello packets is sent every 10 seconds. And in this case, the router 1 will have an authentication where router 2 doesn't have authentication. That means there will be a mismatch. Then they will not form neighborship anymore unless I put authentication here. Okay. Now I go back to router 1 and I say OK, and you can see now it's waiting. It's waiting to see if router 2 will reply to this authentication. And here you can see directly the neighbor with router 2 is gone. Let me go to router 2 now again, very fast here, and I go inside the Ethernet 2 interface, which we don't have any authentication on it. I will put it simple, and I put the same password 123456, and then I say OK. And then you can see in a moment we should have neighborship between router 1 and router 2. Here we go. The neighborship is here. Okay, and we can see in a moment also that router 2 will know again about 11.11.11.0, which is the bridge interface connected to router 1. So they share together the routings. Okay, so this is really very simple how you can do authentication on MikroTik router. Remember, when you use simple, that means that the password 123456 is sent clear text between router 1 and router 2. That means in case someone is intercepting this traffic, he can capture it and see what is the password, and then possibly he can use it to form some type of attacks to our network. So point number 6, configure OSPF authentication using MD5 method between router 1 and router 3. Put the password MAICT consult. Now we need to do the work on between router 1 and router 3. So we have to go to Ethernet 3 and we have to go to Ethernet 3 on both routers. And we need to use the MD5, okay? And that's the hashed or the encrypted way. That means that our password will not be shown in case someone is able to capture our traffic, okay? Router 1 and router 3. Okay, I will go to router 1, inside interface. I go to Ethernet 3, and then from here I will put the authentication MD5. We will put it MAICT ICT consult. By the way, if you don't want that this will be shown, you can just go here to settings and say hide password. That means that if you are doing some configuration on the MikroTik router and you have some colleague sitting next to you that you really don't want him to know what is the password, you can just do it like this. But for now, I will take it out. So MAICT consult. And again, now we have to lose now neighborship from router 1 to router 3. You can see there's no more neighbors. And if we go to routes, what we can see here, we still see that it's getting this 33.33.33.0. And that's because if you go here to this picture, so now there is no neighborship here, right? So this is gone. But is router 1 is knowing about this network now from router 2, because here there is OSPF enabled. So directly router 1 will ask for router 2 if he knows about this network, and router 2 will provide it because there is OSPF enabled between the link between router 2 and router 3 is working, and here also for the OSPF. So we get it from router 2. And if you look here, you can see this is the network 33. You can see that this is the destination address, and the gateway for router 1 is 192.168.12.2. And if you look to the picture, so the router 1 is saying to reach this network, I have to send all my packets to 192.168.12.2. That means to this interface, and that's the gateway for router 1. And that's what is nice in OSPF. It's automatically, while on the static route, if it's gone, then you need to manually do this work by yourself, okay? So now, neighborship is not formed still. I will go to router 3, and from here, I will have to go to interfaces, and then I'll put MD5, and then MAICT consult, and then I will say OK, and I look directly to the neighbors to see if it will form neighbors with router 1 now. And directly we can see there is neighborship between router 1 and router 3. Okay, so this point is also done. So you can see now we have, if we go to this picture, we have made authentication here. MD5, we just made it now. And here's simple. So that's no problem. We can do that, okay? Between two connected routers. Each one has an authentication different than the other. Let's see what we have to do now in the upcoming point. Change the key ID to 10 on router 3. Enable still formed. Okay. If we go now to router 3, and on the interface that we enabled the authentication, that was Ethernet 3 here. They're asking us the authentication key ID. We have set here the password, the same as on router 1 for Ethernet 3. And here the authentication here is 1. They said put it 10. And from the other side, on router 1, it's still 1. Okay? Authentication key ID here is 10, and from the other side is 1. And they said, do we still have neighbors? Let's see. I just changed it to 10. And you can see here that router 3 is still forming neighborship with router 1. And if you want, we can go to router 1 and we can go to interfaces. And then inside Ethernet 3, you can see that the password is still the same, but the key ID is 1. So on router 1, the key ID is 1. On router 3, the key ID is 10. They have same password and they're still forming neighborship. That means that the key ID is not important. What is important is to have the authentication key here, or the password that should be matched together. Okay, so point number 7 is done. Change the key ID. Are neighbors still formed? And then yes. Now put the router 3 Ethernet 3 interface authentication simple. So we have to move it from MD5 and we have to put it simple, but we need to leave the same password. So we keep MAICT consult as the password, but we only need to change the authentication from MD5 to simple, and then we need to see if the neighborship is formed. Let's do that. I will go to router 3 to Ethernet 3. The authentication key ID, we don't want to touch it. Here they said change the authentication and make it simple. Okay, so there is still authentication, but this time is set to simple. While from the other side on router 1 on Ethernet 3, it is still MD5. Okay, so before we check what I'm doing here, I'm putting the same password on Ethernet 3 of router 3 and Ethernet 3 of router 1. They have the same password, MikroTik consult. But here it has authentication type simple, and here it has an authentication type MD5. Both they have same password, which is MikroTik consult. Okay, and we need to check if they can form neighborship. I go back to router 3 and then neighbors, and you can see router 3 is not forming neighbors anymore with router 1. And if I also go to router 1 and then neighbors, also router 1 is not forming neighborship with router 3. And the reason behind that, because the two authentication are different. One is simple, one MD5. Even though that the password is the same, but if you put two different authentication on each of the interfaces, they will not form neighborship. So is neighborship still formed? No. Why? Because we have two different authentication set on the connected interfaces. Point number 9, put MD5 on router 3 again. Do you have neighborship? So let me go to router 3 again, Ethernet 3, and then we move it to MD5 as it was. And say OK, and we look here, directly we have neighborship with router 1, because router 1 is still MD5. Okay, yes, we do have neighborship again. Point number 10, keep the link between R2 and R3 without authentication. Why do they have neighborship? So we have this link that we didn't work on it yet, this link over here between router 2 and router 3. So they say keep it without touching it, without putting authentication. Why is it working? Why we have neighbors? If we go to router 2, and this is router 2 now, and I will look to neighbors, she formed with router 3 neighborship. But also on router 3, if I go to neighbors, he formed with router 2 neighborship. So they say, why do we have neighborship? Okay, because as we said before, if I look to the interface which is inside on here on router 2 is Ethernet 1, and here is Ethernet 1 also. So if I go to router 2 Ethernet 1 interface, we said by default the OSPF on MikroTik, when you enable OSPF, it has non-authentication. Okay, you can see this mode here is the default mode. Okay, so because we didn't change the authentication on this interface of router 2 Ethernet 1 interface, and we also, this is router 3 now. If I go to Ethernet 1, we didn't also change the authentication, so both of them are set to none. That means they can form neighborships because the authentication are not there. Okay, and that's the reason why both routers having neighborship, because there is no authentication on both of them. Okay, so this point also is done. So the lab for the OSPF authentication on MikroTik routers is completely done. Now I hope you enjoyed it, and I'll see you in the upcoming lecture.